All right, now let's take a look at some definitions of the main concepts in descriptive statistics and in the fields of data analytics. So we're going to talk about some types of data and sources of data. So the data itself is defined as detailed facts that characterize one or multiple attributes of members of a sample or members of a population, right? So detailed facts about attributes of a population. And data can be presented in multiple different formats, like text, like words, like numbers, like time, date, image, audio, video, and so on. I said data is about detailed facts about attributes of a population. And when we're talking about attributes, we usually, these attributes will take a different value from a person to another person, from a member of the population to another member of the population, or from a member of the sample to another member of the sample. Whenever an attribute takes a different value, can take a different value from a time to another time, from a member to another member, that is called a variable, right? So I'm going to go ahead and give you an example here. So imagine your class. We have, let's say, 35 students in our class. So our class is a sample of Cal State San Marcos student, right? The population of Cal State. So I'm going to define it as this way: population. We'll get that in our slides, but I'm just going to define it right now. List of all members that we are interested to study them. So all the population, all the members all the members that are of interest to us in terms of like answering our research question. So list of all members that are under study by us, by the analyst. So population, and then we have sample. Sample is a subset of population. So population, let's say, I'm going to take our sample as our class, the list of everyone in our class. So population here, let's say, is going to be CSUSM students, active students or enrolled students at, let's say, a specific year. And then sample would be the subset, a subset of population. Doesn't matter how you select them. Any subset can be a sample, right? As long as there is one member, it's called a sample. Even if there's non-members, we can have a void sample, which basically has no member, but that's not really important right now. So, but for our example, let's say BUS 324 or 322 class of 2020, for example. That's our sample. That's a specific sample. Now, for this sample, if we make a table like this, and we have some attributes for the members of this sample, which is itself a subset of another population, we may have ID, student ID, we have name, we have age, gender, GPA, time of like birthday, time of arrival to class, and so on, right? The mood, a picture of you, a sample voice of you, and so on. These are all the attributes that we're talking about that can actually characterize, that can identify, and are related to our sample here, right? So these are the attributes, and each attribute here, name can take on first name, last name. This is something that can take on different values. So that this is called a variable. ID is a variable, age is variable, gender is variable, GPA, etc. All of them are actually variable since they can take different values from a member to another member, from a time to another time, right? Observations, set of values corresponding to a set of variables. Here in this example, if I pick one student, one row in this table is called an observation. One row in our data set is called, each row is called one observation. ID, let's say 1, name, let's say John, age 23, gender male, GPA 3.5, time of arrival, let's say 10 a.m., for example. 10 a.m., etc. So this row, we just observed one member of ours, we just made one observation that corresponds to, that is related to one member of the sample here. So that is called an observation. Variation is basically the changes. It's a very general concept here. The changes in the values that a column, that a variable can take from a member to another member. And when we just look at the whole column for a sample, we usually see that, so we are talking about variables, so they're supposed to change their values. And variation is basically corresponds to that, the fact that their values are changing. And as the range increases, let's say we may have age between 18 all the way to 60, for example, 65, 85, etc. That shows that in a specific sample, we may have a larger variation in age. For another sample, in another class, we may have a smaller variation, less variation when it comes to the age, right? So that's basically a general concept. Random variable, uncertain variables. So far in my example here, all of these, name, age, gender, these are not random. Random variables are the ones that it's not, you won't be able to, you basically do not know the exact value until a specific point in time. For example, time of arrival, before this is recorded, that can be a random number. So people may arrive to the class at different times, but before before you record their arrival time, that can be a random variable, right? But GPA, once you know it, it becomes certain. It's gender is more certain than even GPA. You once you know it, you're done. Usually it's harder to change. Age, same thing. Name usually is not gonna change for a person from a time to another time. But again, this is something that is mostly related to the probability studies, and we're not dealing with random or uncertain variables at all in this course. All right, so moving on, we have an example here. This is Dow Jones, the list of the companies in that form the Dow Jones Industrial Index at a point in time. this is pretty recent. As you can see, most of them are right. I mean, already in the list right now. And so Dow Jones is basically the list of top 30 industrial companies in the United States in terms of their importance, mostly in terms of their market cap, market share, right? So the list of top 30 companies. And this would be a sample of all the US companies. So our population, if you will, that can be all US companies. And a sample of that, a small sample of that, only 30 companies, that would be a subset of that. That would be a subset. It's called sample. We have that definition in the next slide. But anyway, so, and then we have multiple factors here. We have the share price at a certain date. We have the volume. We have industry. We have symbol and the name of the company, right? So these are the attributes similar to the example that we had regarding our class. Next, types of data. And we're going to talk about population and sample. We already defined that. We're going to talk about quantitative versus categorical data point. We are going to talk about cross-sectional versus time series. This is important. And we are going to talk about sources of data. So, I mean, a classification of sources of data. So moving on, population, we just defined it, all elements of interest, all members of the group, the largest group that are of interest to us. And we are, I mean, the analyst here, the business analyst is studying them. Usually in our course, the analyst is interested in knowing something about the population, the whole population. That can be sales, that can be the customers, it can be the suppliers, employees, etc. Sample is any subset of the population is called sample. We have the concepts of random sampling. We're going to talk about this in the second module of the course when we get in the first module when we're dealing with statistical inference. We are going to study the random sampling. We're going to see how to extract a random sample from a population. It's basically, the idea is that you want to set a sample, you want to select a subset from a population without knowing the members before picking them, right? So you want to basically give every member of the population equal chance or somehow some chance to get selected, to be part of your sample, right? And if you get a random sample, your sample is going to be a true representative of the population, right? If your random process, if your sampling process is truly random, your sample is going to be a true representative of the whole population. Quantitative versus categorical data. I'm just going to come back to my example here. As you can see here, the numbers, here we have numbers for age and GPA. These are numerical, or quantitative. They can take on numerical values or quantitative values versus gender, M, F, and X, let's say. This can take these are, you can't allocate or assign numerical values to different classes of gender, right? That's not how it works. So each class, each category is different, and they just have a name, they just have a label, right? So this is called a categorical. Doesn't have a numerical value, numerical We don't identify it as a numerical or quantitative value. They're called by their the label of their category. All right. As moving on, you can do arithmetic operation on the when you have categorical data, right? You can take sum, you can divide them, you can subtract categorical values. A very important definition here: types of data, cross-sectional data versus time series data. Cross-sectional data, when you collect data from several members of the population, usually at the same point in time. Example of that is exactly what we just saw here as our Dow Jones Industrial Index example. Here, the price that we have here, share price, is collected in a same day, right? For all these 30 companies. Whereas here, this example, this is the Dow Jones Industrial Index value in different days from 2005 to 2015. I mean, this can be a monthly value or weekly value. So as you can see, we have recorded the values in different points for one variable at different points in time, right? So that's the difference between cross-sectional. Cross-sectional is like taking a picture of multiple people at the same time, at the same point in time. Whereas time series, I mean, usually we're talking about one person, one variable, one member of the population, but recording the movement at different points in time. So this is like a dynamic movie, whereas cross-sectional is like a static picture of multiple members. Next one, and the last definition that we have in this part is with respect to the sources of data. The book identifies two sources of data. Data can have, other sources as well, depending on the field of study. But usually when we are dealing with business applications, usually data is coming from two sources. It can come from experimental study. Experimental study is experimental or non-experimental study or observational study. The difference between these two is that in an experimental study, you usually have a research question. You know exactly what you're looking for. And so you have a variable of interest. Let's say you want to know what is the age of people who come to the school, for example, right? At certain days, like work days, for example, or weekdays, for example. What you can do, you can design an experiment. Someone can record the age of people who arrive to the school at a certain date, and that could be an experimental study. So you are collecting data only for your research question. You know exactly what you're looking for. And you can control or manipulate the data depending on, again, what you're looking for. Whereas non-experimental study or observational study is when your data is coming from, it's also called a secondary resource. This is first-hand resource, first-hand data source, second-hand data source. Usually you have the data has been collected, but with no specific purpose. And you just go and look at the data and try to extract those pieces of information, those pieces of data that are somehow related to your study, right? An example of non-experimental is survey. We may have experimental survey as well, but surveys, usually there are some general question in surveys, and surveys may have multiple purposes, and they can be used for extracting data, extract observational data, just getting general information from the audience, from the participants, and as the analyst, we can just look at the specific part of the data set and try to answer the research question that we need to answer.